Now let's come to the experiment number 7. This is a very straightforward experiment where you have to determine the coefficient of viscosity using the concept of terminal speed. So the apparatus is also very simple. You just will have a spherical ball whose radius you have to measure, and then you will have a long tube, long transparent tube, which will be containing some viscous liquid like glycerin or oil or mustard oil, something. Now when you drop a spherical ball at the face, at the top of this tube which is containing the viscous fluid, after some time, after traveling some distance, it will start moving with the constant speed, and you will just keep a stopwatch and you just mark 2 or 3 points in that transparent tube. So whenever that ball crosses those marks, you will measure the time, and by calculating by the ratio of displacement over the time measured, you can calculate the speed, which will be nothing but the terminal speed. So in this experiment, basically you observe the speed by observing the distances or the markings crossed by that spherical ball at the given instance using the stopwatch. So it is very simple, and from this speed v, once you know the speed v and once you know the radius r of that spherical ball using your instruments, you can put them in the formula of terminal velocity to find the viscosity coefficient. So it is very, very simple. One thing here is extra is that you also have to draw the graph, right? So the graph will be between which variables, and from graph what we need to determine, and how does that helps us to find the viscosity. That is the point of discussion here, although the concept is very simple. So let's discuss the experiment number 7, where we have to determine the coefficient of viscosity neta of a liquid by measuring the terminal speed of the spherical body. So first thing first, principle, which is simple. When a spherical ball of course it will have a radius r, moves under gravity in a viscous liquid, it attains a uniform speed called as terminal speed. Alright, so I am writing the formula directly. We don't have to derive the formula here, otherwise you will be confused in the concept itself. You can see this derivation in the detailed video generally. This is also in the syllabus of the NEET, where we calculate the terminal speed from the Stokes law. But here you don't have to do that. We'll use the formula. Generally you should remember this formula also. This is 2g sigma minus rho times r square by 9 neta. This is the formula you must remember. Alright, of course this is the terminal speed. Now this is the radius of the ball, spherical ball. This has to be measured using some instrument, most probably screw gauge. Then this is the acceleration due to gravity. Now this, this is the density of ball. This is the density of liquid. It has to be given. These two should be in kg per meter cube. Alright, and this neta is the viscosity. So when you rearrange this formula, you get the expression. So by rearranging the formula, you get neta. Neta is equal to 2g sigma minus rho into r square by 9v. All right. So first thing is this. This is the first thing you remember as a formula. Now this thing must be observed using instrument setup. All right. So basically from here, this is observed, this is measured, not observed, this is measured, but this V has to be observed and calculated. So let's see, how do we observe V? How can we observe V? That is the question. How will you observe the velocity? We don't observe velocity, we observe time and distance. We divide time and distance, which will give us the velocity. So how do we calculate the time and distance? That is the procedure. So now let's discuss the procedure. It is very, very simple. First of all, you need to take a long tube which is open at one end but closed at another end, and keep it vertical. Now fill this completely with this viscous fluid. You don't need very long tube, generally 100 centimeter or 1 meter tube. For example, let me take this L as 100 centimeter. Just for an example, generally which are present in the laboratories. Now what you do, you take the rubber bands, you know rubber bands, and you put the rubber bands. The first rubber band, let me call, is placed at some distance A, then the second rubber band B, and then the third rubber band C. These are the rubber bands, yes, rubber bands, and you place this at equal distances. Equal distances. Let's say this is also D and this is also D, equal distances. Alright, very simple setup. Just take a long, 1 meter long, let's say, test tube, fill it with some mustard oil or glycerin, and just put the bands, the rubber bands, at some points which are separated by these distances. Should be pretty large, right? Otherwise, if you keep these distances little large, suppose if you take them as 30 centimeter, for example, you can take 30 centimeter each, just for an example. So by taking them quite big, you will have less error, because the error measured will be just 1 mm. So if you take the larger distances, the relative error will be less. And also this, mark this A point little bit even greater than these distances, so that you will give enough space for that sphere to attain the terminal speed. So the purpose is to find the terminal speed only. So it will travel for some distances, or generally 10 to 20 centimeters is enough, but for safety, you can take, for the precision sake, you can take the even larger. So you will make sure that when you release the sphere here, suppose if you release the sphere here, by the time it reaches here, it will attain terminal speed. Right? Now it will move with the constant speed like this. Alright, so you can see these are the different positions of that sphere, right? So what you do is, you will measure the time at this. Let us say this is t equal to 0. Then you will measure time. This will be t equal to t0, and this will be t equal to, let's say this is t1, and this will be t equal to t2. So you have you should keep 2 stopwatch. You will you will keep fingers on both the stopwatch, and you observe this. You release the ball and you observe. Generally it takes sufficient time. It takes 10 seconds, 10 to 20 seconds to come up to here. So as soon as it crosses the band A, right, what you do is you start the stopwatches. So both the stopwatches, stopwatch 1 and 2, Both will be t equal to 0 at when it crosses A. Then when it crosses B, you will stop the watch and calculate T1, watch 1, and when it crosses C, you stop the second watch and calculate T2. And from here you can determine the velocity. The velocity will be given by that distance upon the time. So total distance is d by t1, and it can also be calculated, it should be equal to 2d by t2. Alright, so generally this is how we determine the speed, terminal speed. Or you can also determine the speed anyway as d by t2 minus t1. Whatever way you calculate, these all give you the same values of velocity. So that is how you observe the velocity. Now from here you put the values, the t is measured, the d is measured, these d and t are measured, they will have some errors as well. The least count of the instruments, this least count of stop clock will add error here, the least count of the meter scale will be added to the D, which will produce the error in V, which we can calculate in the problems. But you should understand that is how we can calculate. We can observe the V using these measurements. Now put these values V into your formula, which was, if you can recall, the neta was 2g r square 2g sigma minus rho into r square by 9v. So you can see now this is the observation, and rest all of the things are given to you or known to you. This r must be given, the radius of a sphere, the densities must be given, and 2 and 9 and g are just the values. So this is how you can determine neta, right? Very simple. Now let's write few notes on this. What we need to see here is you need to plot a graph. So in your exam, it might be possible that they may give you a graph, because when I saw this experiment in the laboratory manual of NCERT, I can see they have made a graph. So maybe they can form a question based on graph. The graph was between velocity in meters per second versus r square, which was in meters. And this graph was observed to be a straight line. This graph was observed to be a straight line for two different balls, as you can see for ball 1. So basically in the experiment you don't use the same ball. You will have a small balls of various radii which are given to you. Suppose 1 centimeter, 1.2 centimeter, 1.5 centimeter, you will have 5-6 balls. So you will observe you will repeat the same experiment for different balls, at least for 2 balls. Let us say this is a ball number 1, for which you will have v1 velocity, and then you will have a ball number 2 which has different radius, a larger radius, which will give you the different velocity v2. Now from here, if you determine the slope of this graph, it will be very simple. It will be v2 minus v1 upon r2. This is r1 r2 square, this is r1 square. So r2 square minus r1 square. So this is the slope you can calculate from this graph. Now thing is, how does this slope will help us to determine? Now if you can recall the formula, the neta was 2g r square sigma minus rho, or let me rewrite it in the form of 2g sigma minus rho into r square by v by 9, right? So if I rewrite it, this can be written as neta will be equal to 2g sigma minus rho upon 9 times slope. So basically this can be visualized as the slope is v by r square. This is slope. So now because you have r square by v, hence r square by v is 1 by slope. All right. So this is the note number 1. So you can put the value of slope from here, tan theta, whatever angle you get here. So this is the first note from the given graph. If the graph is given to you, find the slope of this graph and put here this. This is the meaning of slope, remember. This is the slope. Slope is v by r square, or 1 by slope is r square by, this is the, remember, right? So instead of giving you the value of v, they may give you the graph, and from here you can directly find the, so they will not give you in NEET problem, I think, neither they will give you v, they will neither give you r, they will just draw graph, and from here you know the slope of this graph will be just v y by r. This line passes through origin, so don't worry, the slope can be written as just y by r square, right? That is v by r square. Remember, the question may come directly from the graph, right? And then put this v by r square in your NEET formula and you get the answer, right? Now the second thing is, one more thing is here, the error in the measurement, of NEET, right? So first let me write the formula. NEET is basically 2g sigma minus rho into r square by slope, 9 times slope. Right? Or you can let me write the exact formula instead of making it confusing to you. Let me write it as r square by v. So when you take the error delta neta by neta, 2g, these are constants, it is 2 times delta r by r plus delta v by v. This will give you the percentage error. So if you want to find the percentage error, you can multiply this into 100, right? So more of this will be discussed in your questions, but you can clearly see this is the least count of, and this delta v is measured using slope. Graph. I hope it is clear.